Good day everyone. Today I will be explaining the general gas law. I will define the law, illustrate it using a gas particle simulation, and I will also explain gas behavior using the kinetic theory of gases. By the end of this lesson, you should understand how pressure, volume, and temperature are related in gases and how particle motion explains this behavior. The general gas law describes the relationship between pressure, volume, and temperature for a fixed amount of gas. The equation is PV equals nRT. Pressure is the force gas particles exert on the walls of a container, while volume is the space the gas occupies. Temperature is measured in Kelvin and represents how energetic the particles are. This law combines Boyle's law, Charles' law, and Gay-Lussac's law into one equation. But in this lesson, we are learning more about the relationships rather than the equation. Pressure, volume, and temperature are linked. Change one, others are affected. What this law tells us is that pressure, volume, and temperature are not independent. If one of these changes, at least one of the others must also change, as long as the amount of gas stays the same. As you can see here, in this simulation, the gas particles are shown as small dots moving randomly inside a container. When the temperature increases, the particles gain kinetic energy and move faster. If the volume stays the same, these faster particles collide with the walls more often and with great force, causing the pressure to increase. Effect of temperature. Temperature, kinetic energy. Higher temperature, faster motion. More energetic collisions. According to the kinetic theory of gases, temperature is a measure of the average kinetic energy of gas particles. As temperature increases, particles move faster, resulting in more frequent and more forceful collisions with the walls, which increases pressure. Effect of volume. Smaller volume, less space, more collisions per second. Pressure increases. When volume decreases, particles have less space to move. This causes an increase in collisions frequency with the container walls, leading to higher pressure. When volume increases, particles spread out, collide less often, and pressure decreases. Kinetic theory of gases. According to the kinetic theory of gases, gas particles are in constant random motion. There are no significant forces of attraction between them, and all collisions are elastic. Temperature is a measure of the average kinetic energy of the particles. This explains why increasing temperature causes particles to move faster and increase pressure. A real-life example of the general gas law is a balloon. When the balloon is heated, the gas particles gain kinetic energy, they move faster and spread out, causing the balloon to expand. When the temperature decreases, the particles slow down and the balloon contracts. In conclusion, the general gas law shows how pressure, volume, and temperature are interconnected in gases. Using the kinetic theory of gases, we understand that these changes occur because of particle motion and kinetic energy. Thank you for watching. I hope this explanation improved your understanding of the general gas law.